Hey guys, so today we're doing section 5.4, day 2. We have 2 logarithm properties that we're going to talk about. I guess 3 logarithm properties, but 2 main ones that we're going to talk about today. The first one is the addition logarithm property, and the second one is the subtraction. So the first one is how to deal with a logarithm if you have 2 things that are multiplied together. So if you have 2 things in the logarithm that are multiplied together, you break apart the logarithm where they're multiplied, and it becomes 2 separate logarithms that are added together, like that. And then there is a subtraction property that deals with division. So if you've got log of 2 things that are divided with each other, what you will do then is subtract the 2 separate log things that are on the inside. So I will separate this into the log of x and subtract what's on the bottom, the log of y. So we have an addition property from 2 things multiplied and a subtraction property from 2 things that are divided. Like I said, there really is a third property, but it's actually a very simple one to think about. And it's if you've got the log of something to a power. That power falls down to the front of your logarithm, and it becomes that number times whatever your log is. So that power would fall down to the front. So these are what we're going to look at, our log properties, when we do our problems. So we're going to be doing expansion of logarithms and then condensing logarithms. So we're going to start with expansion. I'm going to do 2 problems of each. An expansion, or 2 expanding problems and 2 condensing problems. So our first one we've got is log base A of, and for our fraction, because we're going to do addition and subtraction properties, we've got x to the 4th y squared over w to the 3rd z to the 5th. So the ones on top, and they're multiplied, are going to be ones that you are going to do with addition. Anything that's on bottom, you're going to do with subtraction because they are divided. So these 2 pieces are going to be subtraction. And I always look at it and I count how many pieces I have because that tells me how many logarithms I'm going to write out. So I have 1, 2, 3, 4 pieces. So that means when I write this out, and I recommend definitely writing it out on paper before I do the problem, in the computers what I'm talking about, I would write out log base A, log base A, log base A, log base A. Don't forget whatever the base is on the problem when you type it in, because that's how you'll get it wrong on the WebAssign, is if you don't. So the first one, start at the very beginning, is x to the 4th. So I'm going to have x to the 4th, but to really do the expansion the right way, you have to take that 4 and pull it down to the front using this property. So this is really 4 log base A of x. Now what I was saying was that anything on top is an addition, so I'm going to put a plus sign, and then I'm going to do the same thing, and I made that too big, with the log base A of y squared. So I would put y squared, but that 2 is going to fall down to the front. Now these 2 guys on the bottom are division, so they will become subtraction. So I will have minus w to the 3rd, but oh, I'm not going to put the 3 up there. It's going to fall down to the front. And then last but not least, the z. It would be z to the 5th, but oh, the 5 is going to follow down to the front and is still subtraction. Everything on top is addition, everything on top is subtraction. And that's what it looks like when you expand a logarithm. So we're going to do one more of expansion, and then we're going to do some condensing. So we've got log of, and this one I didn't put a base, it's just log. So it would have been the invisible 10, but we don't have to write it. So log of the cube root of x over y squared square root of z. Now you might go, well, wait a second, those are roots. How are those powers? They are powers. That's old stuff. Old stuff. This is really log of, and think way back. Cube roots are actually the 1/3 power we got y squared. And square roots are really the 1/2 power. Gotta think way, 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 way back. Whole bottom is the root and the top is the power deal that I taught you. You're just gonna have to know that and remember that. So we've got 3 things, 3 logarithms. So log, log, log. The one on top is positive because he's the plus thing. So I would have x to the 1/3. So I'd have x to the, oh, I'm not going to write 1/3. I'm going to pull him down to the front. Oh, it's exciting. The bottom 2 things would be subtraction because they're both division. So I'd have y squared. Oh, I'm not going to write squared. I'm going to put it in the front. And like I said, subtraction because it's on the bottom. And the last thing's e to the 1/2. But oh, I'm not going to write 1/2. I'm going to put it on the bottom or on the front because it always falls to the front. And that would be your solution for that, expansion. Expanding is not hard. Expanding is pretty easy. So now we're going to take a problem that looks like that answer here and go backwards and write it as a logarithm. Same rules. But we are going to condense instead of expand. So this is condense. So our first one is 2 log base a of y plus 1/2 log base a of x plus 2, and then minus 3 log base a of, oh, I'm going to run into this, of 2x plus 1. How many pieces do you see? 3 of them. So the first thing I do is I go back and I put the powers where they go. So this 2 goes in the power of the y. This 1/2 goes in the power of the x plus 2. And yes, you leave it in parentheses. And then this 3, not -3, just the 3 goes in the power of the 2x plus 1. The plus means they're multiplied, and the plus also means they go on top. The minus means it's division, which means that piece goes on bottom. So what I do is I write a single logarithm. I just write 1 log base a, and I draw myself a parenthesis as well as a fraction. I know there's division, so I know there's a fraction. The pieces that are plus go on top because they are multiplication and they're positive. So y squared is going to go up here, and x plus 2 to the 1/2 is going to go up here. This one's subtraction, so 2x plus 1 to the 3rd is going to go up here. But we did this in the last problems. The 1/2 power, wasn't the 1/2 power something? Oh yes, it was the square root. So this is really log base a of y squared square root of x plus 2 over 2x plus 1 cubed, and that's the answer. Please make sure to put parentheses around it. Last problem. All right, so we've got 4, and I'm going to use ln this time. ln of x minus 2 ln of 1 over x minus 3 ln of xy. Okay, I'm going to set my paper down. Don't need it anymore. So like I said, the first thing I want you to do is I want you to put all the powers back where they go. So this 4 is going to go on this x for x squared, not the minus, just the 2. The 2 is going to go up here, and this 3 is going to go up here. I have 3 pieces. 2 of them are minus, so 2 of them are subtraction, and they're going to go on the bottom. So I've got a single ln, parenthesis, fraction bar. Let's put in there what we have. So I've got x to the 4th. He's on top because he's in the front. The front things go on top. This guy, 1 over x squared, is going to go down here on bottom, 1 over x squared. And then xy cubed is going to go on bottom. All right, now here's the deal with this problem, and you'll have one just like it. You got to clean the inside up a little bit because you can do powers. 1 over x squared, you give the square to the 1, you give the square to the x. So I have really x to the 4th over 1 over x squared. I gave the square to the 1. I gave the square to the x. Then I'm going to do the same thing here. I'm going to give the 3 to the x and the 3 to the y. So I'm going to have this times x cubed, y cubed. Do you notice inside here, this 1 over x squared and this x cubed can cross reduce? If I've got x squared here on the bottom and x cubed here, I can get rid of 2 of the x squares. X squared could cancel with x cubed and leave us with ln of x to the 4th over xy cubed. And that should still look a little weird because there's one more thing you can do. Can this x to the 4th and this x reduce? Why, yes, it can. You could get rid of this x with this and leave behind 3. So your final answer is ln of x cubed over y cubed. And you'll have a problem very, very similar to that. So follow my steps and you should be able to get that one done correctly. So I'll see you guys next week.